Hi everybody, I'm Callan Bentley from Piedmont, Virginia Community College, and I'm taking a hike up to the top of Sacagawea Peak in the Bridger Range of Montana. But you could also say that I'm in the Bahamas, because the rocks that surround me here are rocks that were deposited in Bahamas-like conditions in the ancient past. So let me show you what I'm talking about here. So this rock here is an example of limestone. And this is limestone of the Big Snowy group. Most of the Bridger Range here is going to be the Madison group limestones, the Lodgepole limestone, and the Mission Canyon. But this is the Big Snowy, and it's pretty much similar. It's a little bit younger than the Madison group. If you put acid on this, it would fizz. It's basically nothing but calcite, and there's very little sand in it, very little mud. And so that implies that when it was deposited, it was really far away from any land that was shedding off sediment, shedding off dirt. So that would be very similar to the modern day Bahamas. And if you look right here, there's something really intriguing. So in this part of the outcrop, you can see that there are light-colored chunks of limestone in slightly darker colored matrix of limestone. And so what this implies, if you look at the texture here, these are fine-grained and this is relatively coarse-grained. We deposit fine-grained sediments when water energy conditions are quite low, and we deposit coarser material when water energy conditions are higher. So what we're seeing here is evidence of an earlier episode of deposition of limestone under calm conditions, and then the older limestone gets ripped up in big chunks by a higher energy event and mixed together and then redeposited. So this is actually evidence here of an ancient high energy event. And if you think about the Bahamas today, that probably implies something like a hurricane. All right, so this is evidence here of an ancient hurricane during the Mississippian period of geologic time. There's also some other intriguing features. If you come over here and take a look at this rock right here, you can see some ancient mud cracks. And these mud cracks are evidence of desiccation, of exposure to the air and drying out of the sediment. You can't get the sediment to dry out if it's underwater. So this indicates that these limestones were deposited under relatively shallow conditions. Now let's see what we see if we go further uphill. In these Bahamas-like seas, there were living animals, and those animals are preserved in these limestones as fossils. So there's a really nice example of that right here. Right about here, we have an example of a coral. So my finger's tracing around this area where you've got all these tiny little chambers, which are individual coral animals. And here's another example. This one's really big. All right, so a nice big coral head here. These are colonial filter feeding animals. And of course, if you went to the Bahamas today, you would expect to perhaps go snorkeling and perhaps see some modern day corals. Modern day corals are a slightly different group. Corals have three major families within the corals, and this is actually an extinct lineage of coral. And here are some examples of brachiopods. Brachiopods are animals with shells, in fact, two valves, a lot like a clam, but unlike clams, they had a stalk. So these are really common during the Paleozoic, but get less common after the end Permian extinction. And bivalves become more common after that point. Here's an example of some other animals. This thing here, that's round with a little star-shaped cutout in the middle, and this little round guy here, and this one here, and this one here. These are all examples of crinoid stems. Crinoids are relatives of sea urchins and starfish. They are echinoderms. The shape of their body is something like a flower, like a sea lily, and these are sections of that stem of that flower. So you could think of their stem as looking almost like a roll of lifesavers. And then these are little segments of that stem. Here's an example of some trace fossils. Trace fossils are not the actual bodies of organisms that are preserved in the geologic record, but they're traces instead. These are burrows that went through some of the sediment that was already there. So these were worm-like organisms burrowing in that sediment, and then their burrows got filled in with sediment of a slightly different color. So it ends up being preserved as a trace of that organism's existence, even though we can't see the skeleton or the body of that organism itself. All right, so we're getting up to the threshold of Sacagawea Cirque, which is sort of where the glacier that used to be here fed into a larger valley glacier down below. And so it's represents from a side view sort of a change in slope. So we've been hiking up a pretty steep slope, and now it's going to get a little flatter. But there are a few knobs of the local bedrock poking out here. There's one behind me. And if you look off this way, up past the snowfield where those hikers are crossing, you can see one to their left and then one beyond them up there. So these are examples of ruche moutonné, a French term that means rock sheep or rock mutton. And those are produced as the glacier flows over them, plucking away at the downstream side and abrading the uphill side. But there's something cool to see right here. So camera person, you stay right there. And I'm just gonna swivel around like this. You can see that the rock outcrop here is kind of a different color than the limestones we were just looking at, more of a maroonish kind of color. And if you get up close and look at it here, you'll see it consists of multicolored chunks surrounded by this sort of reddish matrix. And this is actually evidence, again, of exposure, kind of like the mud cracks, but this is actually evidence of post-lithification exposure. So what must have happened here is that limestone was deposited as sediment, and it was lithified, turned into solid rock, and then that was exposed at Earth's surface, and then it got rained on, and the rain created caves. And those caves basically were unstable structures, and the roofs collapsed, and it created a collapse breccia. So this is actually evidence of ancient karst topography preserved as a distinctive rock texture, rock type. We would call it paleokarst, all right? So really intriguing evidence of past conditions here on Earth. So here's an example of some of these multicolored chunks, yellow and sort of blackish and white and red, surrounded in this reddish matrix. And here's another example of that right here. All right, so we're getting up to the bowl of Sacagawea Cirque, and this is a great place to look at different sediment types. There are, several different varieties of sediment that you often find in the northern Rocky Mountains, especially in the Alpine areas. One of those you can see over there, like by that snowfield, you can see this sort of smooth slope of more or less the same size boulders. That's an example of what we call talus. So talus is basically just boulders that are produced from the cliffs up above through the process of freeze-thaw weathering, and then they get dropped down the hill, and they basically pile up in a big apron at the foot of the hill. Sometimes if the hill is covered, the talus slope is covered with snow, like you can see, a little bit there just behind me, then the boulders can kind of sled down that snow, and they build up in a big sort of ridge that's parallel to the base of the apron, and that's called a pro-talus rampart. Basically just a different variety where you've got snowfields that sort of persist for a large part of the year. And then behind me here, you can see another variety of sediment This one looks a lot more disorganized. There's great big boulders and smaller stuff as well. And it's basically present in a ridge that kind of stretches across the end of Sacagawea Cirque, sort of perpendicular to the glacier flow direction. And that, of course, is glacial till. So it's basically a moraine deposit right there. So a moraine is a big pile of till, a hill of till, if you will. And that's a nice example of one right there. Often the high clay content that you get, small particles in a deposit of till, results in lower permeability of water, and so they tend to retain water better, and as a result you'll get things like those coniferous trees growing on top. All right, so notice how there's no coniferous trees growing on the talus slope because it's larger particles and much better drained. Water just percolates right through it. But here on the floor of Sacagawea Cirque, you can see there's plenty of trees, and that indicates that it is sort of carpeted, if you will, by till. Well, I'm huffing and puffing and climbing ever higher up into Sacagawea Cirque. There's the view back to the east, looking towards the Crazies. And now that I'm getting up into the Cirque, I've got steep walls of rock. The Mississippian Madison limestone with its many thin beds, specifically that's the lodgepole limestone, and they're rising up in these steep cliffs above me. And one of the things I hope you'll notice about those cliffs is that the strata are not horizontal. This isn't someplace like the Grand Canyon where the sedimentary layers are still in their original horizontal orientation. Instead, what we see here is that they've been rotated out of horizontal by the mountain building forces of one of the two big Rocky Mountain orogenies. And this is actually evidence here of the Laramide orogeny. The Laramide orogeny was an interesting mountain building event that got started in the Cretaceous and finished up in the Paleogene period of geologic time in the early Cenozoic. And it took older rock layers and it warped them into these very large regional anticlines and synclines that basically were controlled deeper down by faults. So there were thrust faults, sometimes one, sometimes two, that arched the rocks up and then brought them up to the surface. And the Bridger Range, where I am right now, where Sacajawea Peak is and where Sacagawea Cirque is an example of one of these Laramide uplifts. You can tell them apart from the mountains that were formed due to the severe orogeny, which is a Jurassic into Cretaceous mountain building event, by the structural style. So the severe orogeny is exemplified by thin-skinned tectonics, which is to say that the sedimentary strata are basically deformed, they're folded, they're thrust faulted, but the basement rock does not participate in the deformation. So it's basically like wrinkling up the blankets on your bed, but not destroying your mattress underneath the bed. Whereas the Laramide uplifts are distinctive because they do involve basement rock. So in this part of the Bridger Range, in the northern Bridgers, there is no basement, there's just belt rock below the Paleozoic sedimentary cover. But further south in the Bridgers, like at the M, which is a location that people like to hike at in Bozeman, you can actually see some of the basement rock there, the really old Archean basement of the Wyoming Craton. So those basement rocks do get involved in Laramide uplifts, and the overlying Paleozoic and Mesozoic sedimentary strata get tilted and folded out of their original horizontal orientation. So the Bridger Range is basically like half an anticline. One of the things that happened subsequent to the Laramide orogeny is that this part of the world got stretched, and that stretching opened up a big normal fault on the west side of the Bridgers, dropping down the Gallatin Valley. And that basically took the nice arch-like anticline of the Bridgers and chopped it in half. So we're only left with the eastern half of the anticline, and the western half is buried underneath the Gallatin Valley. The Laramide orogeny deformed these rocks, distorted them, and as I mentioned earlier, there's this very large-scale structure that is parallel to the axis of the Bridger Range, which is an anticline. But there are also smaller scale structures in here as well. And one of those is on the cliff up here behind me. You can see up there, there are some smaller scale folds that take the thin layers of the lodgepole limestone and bend them into folds that go up and down and have a wavelength of, oh, I don't know what that is, maybe 20 meters or so. But definitely much smaller scale than, you know, the kind of 10-kilometer wide anticline that cores the Bridger Range. So the hike is now at the point where I'm climbing up the head wall of the cirque, and you can see that's this fairly steep slope here behind me. You can see some hikers up there climbing up towards the pass or the saddle. This is where, when the glacier was filling Sacagawea Cirque, this is where the Bergschrund would have been. And the Bergschrund is the major crevasse that sort of separates the glacial ice mass from the bedrock that it's gouging into. And you can see what happens when that glacier gouges into that bedrock. This is the view downhill into the Cirque. You get this beautiful amphitheater-shaped bowl cut into the mountains. Okay, I've hiked up to the saddle. And the saddle is sort of the crest of the ridge, but the low point on the crest of the ridge. So behind me, you can see a peak, and then ahead of me is Sacajawea itself. And so this is, you know, basically a spot where I'm on the crest of the ridge going east-west, but if I go north or south, I've got to climb uphill. And one of the nice things here is, having climbed up out of Sacajawea Cirque, I can now look off to the west, and I can see the Gallatin Valley off in the distance there, and the Gallatin and Madison ranges and the Tobacco Root ranges off in the far, far distance. But in the near ground, there's another little cirque here. And in that cirque, there are other sedimentary layers. The further west I travel across the range, the deeper in the stratigraphic section I'm traveling. So it's kind of like, you know, if you look at a layer cake stratigraphy, like at the Grand Canyon, this is kind of tipped on the side. And so the younger strata are off there to the east, and the strata get older as you go to the west. And as you work your way down into this cirque here, you basically go back through the Ordovician and the Cambrian, and then most of the dark brown colored rock you see off there in the distance, that's the La Hood Formation, which is a very coarse-grained siliciclastic unit that's part of the belt supergroup. And that's Mesoproterozoic in age. So that's the oldest stuff that we see here on this hike. In the southern part of the Bridger Range, the belt rock is absent, and you have basement rock there instead. Archean granites and granite gneisses of the Wyoming Craton, but not here. So yeah, the next thing to do is to sort of walk along strike to the south and start climbing up to the peak of Sacajawea itself. So here's a look at that northern side of that cirque from a position that's a little bit to the south. So about right here is the great unconformity between Mesoproterozoic rocks on the west and Paleozoic rocks on the east. So these are Cambrian strata here, and we head that way towards younger and younger strata, getting over to the Mississippian in the far part of the field of view. Well, I've made it to the top. So here I am standing up on top of Sacajawea Peak, and you get a really great view here. You can look down into another cirque here behind me. So that's the third cirque of the day. Behind me off in the distance to the east are the Crazy Mountains, which are sort of unusual because it's actually like a volcanic range, which is unlike the Laramide uplifts that surround it. And then if you look off to the north, you can see the Thunderer, and then off to the west, that's the Gallatin Valley over there. And off to the south, you're looking down along the axis of the Bridger Range, Bozeman off in this direction. And off in the distance, the Gallatin Range and the Beartooths. So a pretty amazing view up here from the top. This is the view to the north from up on top. The peak there is called the Thunderer, and that's the next one to the north. After the cirque, Sacagawea cirque, you can see the trails switchbacking there just beyond that snowfield. And then the final switchbacks as you come up to the saddle, and then you've got the cirque on the other side of the saddle. And then the heartbreaking steep slope that leads all the way up here to the top.